Problem number 11. A projectile is thrown from a horizontal surface and reached a maximum height h and also lands a distance h from the launch point. Neglecting a resistance, what is the maximum height for a projectile thrown directly upward with the same initial speed? Solution for problem number 11. For a maximum height, we know that h equal vy square over 2g, and from the range we know that h equal vx multiplied by total time, but the time equal 2vy over g, and combining this we have vx equal h over t, or gh over 2vy, or just 1/4 of vy. So from the first equation we have vy square equal 2gh, and total speed v square equal vx square plus vy square, which is 17 over 16 vy square, which is 17 over 8 gh. And last, for the second case, we have height equal v square over 2g, or 17 over 16h, which is answer A, and this was a solution for problem 11. Problem number 12. A block of mass m is initially held in place by two massless strings, as shown. The tension in the diagonal string is T1. Next, the horizontal string is cut, and immediately afterward, the tension in the diagonal string is T2. Which of the following is true? Solution for problem number 12. Let the angle from the vertical be theta. Before the string is cut, balancing vertical forces give us T1 cosine theta equal mg. And from here we have T1 equal mg over cosine theta, which is greater than mg. Right after the string is cut, balancing force along the direction of the string give us net force 0. It means that T2 must be equal mg cosine theta, which is less than mg. Both of these equations give us a relation B, which is a correct answer. So that was a solution for problem number 12. Problem number 13. A uniform box with mass m is at rest on the horizontal surface, and the coefficient of static friction between them is mu s. A force directed at an angle of 85 degrees above the horizontal is applied to the center of the box with a linearly increasing magnitude f equal beta t. The box will eventually slide or lift off the ground. Which of the following is correct? Solution for problem number 13. The box will slide first, no matter what the other parameters are. The box will only lift off the ground once the normal force goes to 0, which occurs when the vertical component of the applied force exceeds the weight of the box. Right before that moment, the normal force will be very small, so the maximal possible friction force is also very small, and cannot balance the horizontal component of the applied force. So the correct answer is D, and that was a solution for problem number 13. Problem number 14. The object shown below is made of 3 rigidly connected identical rods with a uniform density. When it stands upright on a horizontal table, what fraction of its weight rests on the left leg? 14. Let each rod have weight W/3. Let the normal force on the left leg be N, and let the distance between the legs be L. If we balance torques about bottom of the right leg, then the only contributions are from the weights of the rods and the normal force N, which is giving us equation. Torque from normal force N equal NL, which is equal to W/3 multiplied by 3 distances from center of mass of each of the 3 rods, which is L/4, L/4, and 3L/4, which is giving us 5/12 WL. And from here we have N normal force on the left leg is 5/12 W, which is answer E, and that was solution for problem number 14. Problem number 15. The following plot shows the speed Vr at which stars orbit about the center of a galaxy as a function of their distance r from the center. Assuming the galaxy has a spherically symmetric mass distribution, which plot best shows the mass of the galaxy mr enclosed within radius r? Solution for problem 15. The graph shows that rotational speed becomes roughly constant once a certain distance from the center galaxy, but the rotational speed of mass m is governed by equation this one. Then we must have a linear dependency mass of distance r to keep v constant, which correspond to choice B. Choice D does not match this behavior because it is more like parabolic for big R. However, at the level of resolution given in the figures, it is somewhat difficult to see that its curve indeed remains parabolic at large R, rather than approaching a linear dependency. Furthermore, it is below linear at small r, which is consistent with the small r behavior for V. Thus, we also accept D as correct. So, B and D are correct answers, and that was a solution for problem number 15.